Jeez.
No, I mean, if anyone plays the French horn, no offense, but I mean, it's not like super cool, right? Isn't a saxophone cool?
Yeah.
Like you think of a jazz guy, like jazzing out?
No, it's not cool. I think of
I
like the 40s.
don't know. I don't know what French horn guys do. All right. I guess I'm passing judgment. I shouldn't do that. So let's get back to this.
Baggy
Here we go.
Close enough.
Willow.
I forgot the question was.
That's fair. What does the positive nucleus have to do with the size of the atom, like the radius?
Well, is it because they're attracted to it?
What is?
The electrons?
So if the electrons are attracted to this, Kieran, face
I'm
forward.
just looking at the talker.
Okay, so if this charge goes up, so the nucleus becomes stronger positive,
Yeah, then it'll get more.
it'll do what to the electrons?
It'll
Pull them closer. So will the radius shrink or it'll shrink? Very good. So I need everyone to be on board with this, that this is the explanation for the trend you just saw. So as this charge goes up, it pulls the electrons in. That's the whole point of the rope. We're going to be playing with it then. So the protons are positive and they are pulling in the electrons. So let's write that down. The higher the nuclear charge, now what that means, in parentheses here, that means more protons. The higher the nuclear charge, sorry, that looks like change. Higher the nuclear charge, more protons, the more, this isn't worded very well, but the more the nucleus can pull on the electrons. But I'm not going to write down that always makes it smaller, because it doesn't always make it smaller. So that's the confusing part. Before I answer that question, I got to really make sure you understand what this means. So write that down. I need a little more space here. No. So here's the confusing part with this. Look over here again, please. How many protons does hydrogen have? One. Lithium. Okay, so what's happening to the nuclear charge as we move down?
Staying the same.
Increases.
Don't worry, period 2 was a little slow on the pickup here on this one.
But why?
Well, now I'm on record for saying that. Oh well. Sorry, guys. All right.
Slow person.
What is?
You have to write this down.
Yep. The nuclear charge.
I can't see your head. What is the nuclear?
He just said it.
What is the nuclear charge on potassium? What is the nuclear charge on K plus? K plus 1. What is the nuclear charge on carbon? What is the nuclear charge on carbon minus 4? So I'll use these same 4 examples in period 2, and I have to retract my earlier statement. They did pick it up pretty quick after we did the examples. They did. So you don't have to just write exactly what I wrote, right? The notes there, so you don't have to rewrite it 4
I
times.
just wrote, like, what is the nuclear charge on colon?
Yeah, that's fine. That works too.
Thanks, mate.
How do we find the nuclear charge, Riley? Read the definition of nuclear charge we wrote down.
The charge of the nucleus,
Due to?
the positive protons,
Okay. So how do we find the nuclear charge for elements and ions?
find the protons.
Find the protons. Very good, Riley. How many protons does potassium have? You can look over there if you want.
19.
19. So it's plus 19. That's the nuclear charge on potassium. Who can tell me what's the nuclear charge on K plus 1?
Plus 18.
Plus 19.
What?
Those are protons, not electrons.
Oh,
The
yes.
protons, not the electrons. I did that on purpose to
Yes.
be tricky.
I
Okay.
hate you.
What's the charge on the carbon?
6 plus
Plus 6 because there's 6 protons. What's the nuclear charge on carbon minus 4?
Plus 6.
Plus 6.
Oh, yeah.
So what you guys need to understand is, if you look to the side, what's this number called? Atomic number. What's that number called? Atomic number. How do you get the nuclear charge?
Atomic number.
Look at the atomic number. That tells you the number of protons. So it's really important to understand what that means before I can teach you the rest of it. Okay. So that's how you find the nuclear charge. So again, look over here. What's the nuclear charge on cesium?
55.
Plus 55. Plus 55. What's francium?
Plus 87.
Okay. So as we move down this group, what's happening to the nuclear charge?
It's going up.
It's going up. So what Willow said, if the charge goes up, it's pulling the electrons in, the radius should
Decrease.
decrease. But what does this thing show us?
Increasing.
It increases.
Are you for real?
Right?
Maybe they're just.
So it increases,
Vikings,
right?
Vikings.
As you move down. So the bottom here is bigger than the top. Why?
Because of constant.
The increase is as you go down. I don't know.
Yeah, but why?
Cool.
The number of balance shells. I don't know. I don't have any more. That's all I
You're
got.
out, tapped out. Ooh, write this down.
Is it
Mouth.
partially
Mouth.
right?
Moving
No.
down a group, the radius increases.
Was I partially right though?
Due to, yes,
Wait, really?
yes,
Sweet.
an increase
Another gold star.
in,
Can I get a gold star?
Have
you gotten your other one? I did. It's right here.
in electron shells. So
Thank you.
it goes like this: 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, oops, 4, 5. Okay.
No, that's
1,
touching
2,
the
3,
nucleus.
4, 5, 6. Okay, I'm going very quickly. As you move down the groups there, period 1, 2, 3, 4, 5, 6, it is more and more rings, more and more shells. That's why the radius increases. Stay with me. This is a +1 in the nucleus. That's hydrogen. This is +3, +11, +19, +37. And the last one there, +55. So the nucleus is getting stronger, but because there's more shells, it still gets bigger. So moving down the group, the nucleus doesn't really affect the size. Moving left to right is a different story. So let's write this down.
All right.
So moving left to right across. How much time do we have? Good. Gotta have time for the showdown. Moving left to right across the periods, radius decreases. And this is because there's an increase in the number of protons. What do we call that?
The
Nuclear charge. An increase in the number of protons, parentheses, nuclear charge. But the atoms have the same number of shells. An increase in the number of protons, but same number of electron shells.
Same number of electron shells, yes. Okay.
So I realize that writing things down on the board and me saying them and you writing them down does not translate to you learning it all the time. I get that.
Yeah, look at
So I try and do demonstrations, try and give you analogies, videos, whatever. Try and do whatever I can. This example here can really easily be demonstrated with that rope. And in fact, today, I'll use her name because I don't think she'll mind. Olivia was sitting here, and I think she was a little confused because as soon as we started using the rope, she went, oh, I get it now. It makes perfect sense. So now she really understands it. And when you get to that point in school, you don't go backwards. Once you get something, you don't get confused later in the year. You may forget forget some things you learned, but then you get refreshed and then you're good to go. So anyways, the point is, if you guys are sitting here listening, doing the best you can, and writing it down, that doesn't mean you're learning it. I get it. This is kind of confusing, okay? But let me explain and then we'll get people up to play tug of war. If you look here, sodium has 11 protons. That's a positive 11 nucleus. What's the electron configuration of Na?
281.
281. Mg is 282, 283, 284, 285, 286, 287, 288. Three energy levels for all of them. As we move, look up here, as we move left to right, the protons are going up. So you have now back to the side here. Plus 11, plus 12, plus 13. So this one here, argon, has 18 protons pulling on the same 3 shells. The same 3 shells that sodium does. So sodium has a weaker pull in the nucleus, so its radius is bigger. Argon has more protons, so it pulls them in because it's the same number of shells. That's what this is all about. That's actually more of an AP chemistry concept, but I teach it because it's crazy not to. We talk about going down the group, you have to learn about going this way too. All right, who wants to play tug of war? 1, 2, 3, 4, 5, 6. Everybody go over there.
I just want to watch.
I know I'm going to have to adjust the numbers here. How many girls do we have?
0.
4. All right, I need. Wait, you got like no dudes in this class here.
Trevor.
I need Andrew, Trevor, and Nick. I need all 3 of you.
All queens.